I couldn't. Can you hear me? I hope. Okay. If you're logged in on the Zoom, let me know if you can hear me because I'm not 100% sure. Okay, great. Okay, we'll continue on and pick up. So yes, I went to PyCon and it was great. And I learned stuff and I vibe coded some new apps and things. And here's my takeaway. Or here's like what I learned and what it feels like what's happening in industry is that like uh everyone is using AI. All of the companies are pushing AI and telling you to use AI as a tool to code faster, increase your output, be able to kind of prototype ideas and become super productive uh, when coding. That's a big part. But um, there's also a um, a big problem because the barrier to entry has been lowered. That like um, so it seems that a lot of people in software development and whatnot, they feel like when a capable software developer, a capable coder, capable software engineer uses AI, they become much more productive, much more effective. They're able to do all kinds of stuff. But if you give the AI to someone who's not skilled or doesn't quite know what they're doing, then um, then they produce a bunch of slop that takes a very long time to parse through and clean up. And because the AI has this capability of generating like thousands of lines of code very, very, very quickly. But reading through and making sure everything is going to work together effectively and uh, not cause problems in other places, that takes a long time. And so um, the kind of this loose definition of slop is that it takes more time to review than it does to generate. So so the traditional way is it takes a long time to generate, and then someone can review it, not like super quickly, but just like the amount of time to review something is, you know, much less than the amount of time it takes to write it in the first place. But with AI, that has kind of flipped around where the amount of time it takes to generate something is just a few seconds, and then the amount of time it takes to review something is much, much longer. And so this is creating issues in the open source community. Python's open source, and a lot of the packages we use are open source. And and they're getting with open source, the idea is almost anyone can go on GitHub and, branch or fork, create modifications and create pull requests so that when, someone else says, hey, I implemented this new function to do this feature, and I think it'll make a good addition, the projects um, get stronger because lots of people are contributing. But now there's an issue where it's like AI agents and bots are just overwhelming the maintainers, the people who kind of the masters of the open source project, that it's taking so long to review all of these things that some places are just either cutting off open source contributions and only like Select individuals are allowed to contribute. So it's this, there's a lot of discussion on like how open source, how software development, how coding is going to adapt to the usage of AI. And but anyway, it's also very clear that many people, and pretty much like the entire industry, expects uh, their engineers, their coders, their people to be able to utilize AI. And they ask in interviews, how do you use AI? What is like your workflow that incorporates AI and things like that. But at the same time, there's also a very there's a great uh emphasis on everybody has a responsibility to review what the AI has produced, and that they can't just take, the thousands of lines of code the AI writes and just trust it and push it. That everybody needs to take responsibility for what their AI agent has produced. And so anyway, I don't know. I'm thinking, I'm trying to think like, okay, how am I going to teach courses and stuff in this future and stuff? And so I think yes, there is a very fundamental need to understand the fundamentals of Python or any kind of programming language. Like you have to learn those basics and fundamentals. And when you do have a good, strong foundation of that, yes, then AI can be a force multiplier and make you much more effective and productive and help you produce all kinds of stuff. But yeah, it's also true that AI is really good at the fundamental stuff. And so, I say this, I think, a lot, but the homework that I assign, you could just feed it to the AI and it'll probably get 100%. Okay. And I wouldn't know any but different. All right. But the point of the homework isn't that the homework gets done. I don't care, right? Like I don't what was the data set I just gave you guys, the Penguins data set or something? And I don't need that analyzed. Like I don't that's been analyzed to death already. Okay. But the exercises, the purpose of the exercises are so like you have an opportunity to do something to try to learn yourself. And and the learning happens with the friction. When you struggle and your brain goes, "Oh man, how do I do this?" And you have to kind of think through and force your brain to think, like that's where the learning happens. That's where what forces your brains to form those new connections and stuff. Um, but yeah, it's also completely like it's not going to work to just kind of like ignore AI and pretend it doesn't exist, or even to just like as a teacher to say like AI is completely forbidden. And and I don't know. Like yeah, I would say for the homework you don't want to use AI because you want to do the thinking yourself. But then as far as like getting jobs in the future, like you got to learn how to incorporate the AI. Right now, and they're always releasing new models of AI and LLMs. I'm using AI generally, but right now I'm just talking mostly about large language models and these generative large language models that are able to produce code. I'm not talking about all of these other kind of decision making and image recognition stuff. So as far as these LLMs and writing code, they do very well with very well-defined um, problems. If you have a very specific, I need this specific output, these are the specific inputs. And so there's uh I think we as for you as students who I think eventually will get to the place where you're gonna be writing code and producing projects, it's important to have that kind of top view perspective and understand how the different pieces should fit together. And because if you don't, then you're going to just get this spaghetti code that you will not understand. Um, and certain segments will work, but then how do all of these segments fit together? It's uh not, yeah. But I don't know. It's very interesting. But anyway, and I learned new technologies, or I don't know, I guess these technologies have been around, but like uh I was trying some stuff out. I vibe coded with the AI some a couple apps in a couple hours I made. So I'm teaching also Stats 10 right now, and so I just want to show off some of the things I made. I made this little confidence interval thing using okay, this is using Streamlit, and I think my I'm on the free tier, so the apps go to sleep after a while. But so this is running on Python, and this says, for confidence interval, there's a secret true value of P for the proportion, and I say collect a random sample, and it's generating random samples. Oh, you can't really see it on the projector, but there's uh different things. This is the confidence interval that has been selected, and it goes from 0.323 to 0.5167. And the question is, how do you feel about the number 0.53 based on this? And you can say, well, it's outside the interval, so we can rule it out with confidence. And I'm confident that P is within the interval that we've created. And then you can push the button to reveal the context. And it shows, okay, it's kind of hard to see on this projector, but it shows all of these other intervals here. And most of them do successfully capture the true value. The program was intentionally picked one that was bad, but just to kind of point out that confidence intervals are not this flawless thing. But anyway, made with Python and Streamlit. Here's another little thing that kind of just shows, like, for proportions, you can flip the coins and they go heads or tails or red or blue, and you can get different kind of confidence intervals and stuff. So anyway, it's kind of fun. And again, yeah, these were the people in industry are encouraging the use of AI and vibe coding in terms of uh, making stuff. And so I tried it out, and indeed, you can get stuff up and running. And so anyway, maybe at the end of the quarter, I guess that's only in a couple of weeks, I could just show you like some of the cool stuff. But anyway, we are so anyway, that's what I have to share and say about PyCon. I'm happy to tell you more. Um, and PyCon next year will be so it was in Long Beach, and next year it will also be in Long Beach. And I think uh so so registration for students is $150, which feels like a lot of money. Okay. But if you are a corporate employee and you ask your company to send you, it's like $900. And other conferences are like in the thousands of dollars. So yes, $150 is a lot of money, but it's also a good value for students, and there's scholarships and things like that. So anyway, and then I think they are going to post a lot of the videos that they recorded from some of the sessions on YouTube. So that's a way to learn. But the Python community, the people who go, you meet a lot of interesting people, and who are doing all kinds of interesting and fascinating work. Everyone's super cool, super nice. It's a great community doing, yeah, everyone's doing like fascinating work in different things. I mean, some people are just doing like helping the tech world make more money, but But yeah, other people are doing like fascinating projects. Okay, anyway, we got to continue talking about object-oriented stuff. So I hope you guys watched the video and we introduced object-oriented things, and I'm just kind of running through all of these cells that were run earlier. And so anyway, um, Python does object-oriented stuff really, really well, okay? And um, here we're like making our own classes, like we're making this time class and we're adding methods and we're doing, we have these functions and things like that. And to be honest, yeah, you might make your own class object in the future, okay? But probably it's going to be something you don't do super frequently, okay? But it is very important to learn the object-oriented system because a lot of the packages, I mean, pandas, NumPy, they're all built around the object-oriented system where you create these classes of objects that have these methods and being able to understand how those things work. Perhaps you don't want to create an entire new class, but you want to create a function that interacts with an object, and understanding how the object-oriented system is going to be very important in order to be able to write a function that is able to interact with an object. So, um, yes, the object-oriented system is important. Okay, so I think towards the end of the video recording, we created this time class object. And yeah, it's very kind of ad hoc. You can just create a new class by just typing out the word class and the name of your new class. And then you can create functions that interact with that. And so this part right here so far, and I know we already did this, but just to kind of recap where we're picking up. So within the time class object, we put in these attributes, the hour, the minute, the second, which is supposed to represent, what time it is. And then we can say, well, I want to be able to display it. And we use this F string or this, string format with the placeholders in order to print it out like this. Okay. But this is just a standalone function. And so what we want to do is we want to put the function inside our class definition, and this creates a method. Okay. And so the simplest way is to just copy and paste the definition of the function into the method. I mean, into the class definition, and that becomes a method. And then you can uh, you can call the method by saying time dot print time, and that calls the function itself. But then if you create the object start, okay, the object start is an instance of class time, and we can just call start dot print time. And because the method references itself, okay, all right, it references itself, it is able to produce all of this. Okay, so this was in the video, right? So the idea of the methods always kind of referencing itself. And so we have a couple methods here where we're going to say, okay, when we create a class time object, we are going to have a method that prints the time, have a method that converts the time into the number of seconds after midnight, and then have another method that adds uh, a number of seconds to the current time. Okay. And so we're going to say, okay, well, if we have our current time is 9:45 and I say add 1,337 seconds, that's going to take us to 10:07 and things like that. Okay. And then, but if you try to do a few things like I want to increment it 1337 and 460, it gets confused and we get an error. And so um, because as far as the method for increment, it only takes in two arguments, self and seconds. And here it looks like, oh, I'm only providing two arguments, but the start is, in this case, start is the self. And so it sees start as the self, 1337, and then it sees 416. That's the third thing, and it complains that three arguments were given, and it doesn't like that. Okay. All right. So we're gonna continue this on, and oh, here. Let me give you your first view quiz answer for today is the letter A. A as in apple. A as in apple. Okay. Sometimes you want your object to interact with another object. So our previous definition of the time class object says, okay, here's our current time, and I want to add 60 seconds, or I want to add 120 seconds, okay? But what if we have two time class objects? Like this one says we're going to start at 10:30, and then I want to add a time class object that just says, oh, okay, you know, the duration is an hour, okay, 1 hour or something. And I want to add that. Okay, so now I have these two time class objects and I want to add them together. So we can create, we can create methods that interact with other objects, okay? Actually, I guess we're going to keep it simple here. We're going to just have a comparison, and we're just going to say, okay, if one time is 10:30 and another time is 11:15, which one comes after the other? Okay, is one after the other. And so here, to show that we have two arguments, we have the self, and then we have the other in terms of the other object. And so is after is going to be a method here. And we are going to, all we're going to do is we're going to just take the current time, the self, convert it to time to int, okay? And then other, we're assuming the other object is also a time class object that comes with this, what do you call it? The method time to int. And so we will take the other time, 11:15 or whatever it is, and convert it to an integer. And then we have these two integers, and we can just do a simple greater than less than comparison. And if it's greater than, that means it's after. It's after the other, okay? And so this method has two arguments, self and other, which means when you call it, you really only just provide the other, okay? So here I'm going to create a new instance of time called start. That's going to be 9:45. Okay. And then we're going to increment it. Okay. And so the ending time is 10:07. And then I'm going to do a comparison. Is the end time 10:07 after, end is after the start. Okay. 10:07:17, is that after 9:45? That comes back with true. Okay. Is 9:45 start is after end? Well, that's going to come back with false. Okay. So all it's doing is it's just doing this comparison by converting the self, the start 9:45 into seconds or integer, the other, which is 10:07, that gets converted into integer, and then says, oh yeah, this number is greater than that number, true, or that number is not. Okay. All right. One of the most important methods that you'll want to implement, okay, is the init method. And up until now, we've been doing this kind of this weird thing where, I mean, this is all we've seen so far, so it doesn't feel weird to you, but for me, I don't like it. But what we've been doing is, we have the class definition, and I say, hey, let's make a new instance of this class. Let's make a new instance of the time object. And then I'm just adding attributes. Start.hour is 9. Start.minute is 45. Start.second is 0. And that is perfectly valid Python code. It doesn't produce an error, and that is a legitimate way to add attributes. But it would not be considered best practices, okay? You generally don't want to just arbitrarily be adding attributes to a an object that's already been produced. And what you generally want to do is you want to have an initialize method, the dunder init method. Okay. And there are certain methods, okay, that are like keywords, and they're indicated by having two underscores. So it's underscore underscore init underscore underscore. And so this is called a double under method, and there's a whole bunch of these, okay? And they serve special purposes when defining, objects and classes and things like that, okay? And so the double underscore is abbreviated dunder, okay? So I don't know if you ever watched this TV show called The Office. They had Dunder Mifflin. It's kind of like that. It's so we call this the dunder init, okay? The dunder init method. There's going to be, I don't know, dunder print and dunder this and that. And so anyway, in this dunder initialize method, we are going to produce the attributes. And so this is going to get called, this method gets called anytime we create a new instance of the class. So anytime I create a new instance of time, okay, we are going to say we want to set the attributes self.hour, self.minute, and self.second. And we will give it default values of 0, 0, 0, okay? But then you can always specify these things. We have all of the other methods from before, but this is going to be the new definition of our time class. And now I can say, all right, let's create a new instance of time. This is going to use all of the default values, and VS Code, it's nice that you hover over it and it says, oh yeah, we're going to use 0, 0, 0. And so that's going to become midnight. I can call midnight.print time, and it says 0, 0, 0 and things like that. Okay, here I can create a new time class object. Here the 9 is going to get passed into the first argument for hour. And so this will be 9 o'clock. Okay, 900. I can specify, here's another new time object. I'm going to pass 9 and 45. And so this is going to become 9:45 and things like that. Okay. Now, so anyway, that is the initialize method, the dunder initialize method. And when you define a class, you should probably always use this so that you're not doing this business where you just create an instance of an object and then you add attributes manually, okay? Like this works, but like this entire time I've been showing you, this is like, it doesn't feel good, right? Okay, so it's like putting in the milk before the tea. That's like a British thing, but I get anyway. So anyway, yes, always use initialize, or you should, and then you'll set the attributes within initialize. Okay. All right. We have this thing. New time is 9:45. I call new time.print time and it comes out 9:45. But what happens if I just call new time or print new time? This is unpleasant to look at, right? It just prints out. This is a time class object located at this memory location, which, yes, that is true, but it's not very intuitive, okay? Now, like if we want to see it, we have this method 9:45:00 and it's print time, okay? And then I can get the attribute. I can do new time.hour and get 9 and things like that. But I want to do something to fix this so I don't have to keep looking at it like this, okay? So this is the dunder string method, dunder string. And this is a special method that gets invoked, okay, or called anytime you use print, okay? So if you call print on this, it is going to invoke the double underscore string method. So I already have a way to show the time as a string, which I like, okay? Right now, it's called print time, okay? So all I'm going to do is I'm going to change the name of print time to double underscore string. And then rather than printing this as a string, it's going to return the string. Okay. So the only thing is the exact same thing. I just say, but rather than calling it print time, it's going to be called double underscore string, dunder string. This is going to get invoked anytime we print the object. And what this method will do is it returns the string. Okay, it returns the string, and then that string will get printed because it's inside the print object. So with this, I'm going to create new time. Okay, new time itself, the object is going to still be produced this way as double underscore time, and this is the object at this memory location. But when I call print on this, it's going to invoke the double underscore string. Double underscore string is going to return this string, which then gets printed out. Okay, and so now I can call print on the thing, and it prints out as 0945, which is, I would say, much preferred to this. Okay, we no longer have this method called dot print time, but I don't think that's a huge loss because who would have remembered, like, generally you don't want to have like a different named thing. You just want to be able to say like, all right, here's the object. I just want to print it out. And this is what gets invoked and it prints it out. Okay. And then if you want to work with it as a string, you can call string on it and then returns the string itself. And then you can do whatever and things like that. Right. And this is similar to like the way, like if you passed integers to it, when you say print 9, it prints it out. And when you say string 9, it takes the thing and it makes it a string. And that's basically what we're doing. We've got the time object. We say print it out. It prints it out onto the screen. We say make a string out of it. It makes a string out of it. Okay. Let me give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear. B as in bear. Okay. So this is where, like, again, Python does a really great job of its object-oriented system. And operator overloading is this very cool thing. Okay. Oh, this is, I don't know if you guys care. Do you guys know who created Python? The creator of Python is Guido van Rossum, creator of Python. Guido van Rossum, this guy. Okay. And I got a selfie with him at PyCon. Let me see if I can show you. Da, 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 da. I saw him at PyCon and I was like, "Can I get a picture with you?" So there he is. Oh. So that's Guido and I was quite pleased with myself for am I still sharing my screen? Wait, how do I, oh no, I don't know what to do now.
Same hat in that photo.
Oh, I am wearing the same hat. Yeah, yeah. This is I wear a hat if like I don't do my hair in the morning. Okay. All right. I think my screen is still sharing and it's still recording. Okay. So anyway, yeah. So operator overloading. Okay, so we had this thing for like we have increment, okay? And that adds stuff, okay? But you can write a method called you use the double underscore add method. And what this will do is it takes the plus operator, and when it sees this, okay, when it sees the plus operator, it is going to invoke the double underscore add method. And it's going to use the object before the plus sign as the self, and the object after the plus sign as the other. So kind of like when you have two strings in Python and you do plus, it like glues them together. Okay, or if you have two lists, it takes list one and list two and it glues them together when you use the plus sign. Okay, and basically you can define how you want your objects to behave when it sees a plus sign. And so what we're going to say is we're going to say, all right, take the current time object, okay, make it an integer, take the thing that comes after the plus sign, the other, we're assuming it's a time object, convert that to an integer, and then add those integers together. That's going to be the total number of seconds. And then uh, take that integer and return it back to a time and return that value. So look at this. Okay, so I have start 9:45, duration hour 35, and I'm going to do start plus duration. Start plus duration. It's going to return a new time object where we added that. Okay, now it looks like this. Okay, but we have the string method, so I can just say, okay, print this out. Start plus duration. Okay, and it's going to take basically the value that it produced. And so 9:45 plus 1 hour 35 minutes, yeah, is 11:20. And so this now gets invoked by using the plus sign, which I think is really cool. Okay, like we've now taken the plus sign, the plus operator, and we've given it new functionality. Okay, by being able to kind of take these time objects and do something with it. Okay, now if I say, all right, well, I like that, and I just want to add 1,337 seconds to 9:45, where is that going to take me? Okay, this returns an error, okay? Because when it sees the add sign, okay, it sees the add sign, it says, okay, I'm going to take the thing that comes after the plus sign, 1337, and it's going to call other.time to int, and it says, oh, well, 1337 is an integer, and that doesn't have a method called time to int. So that gets confused, right? It says attribute error, integer 1337, right? It says, hey, you called this, and when we do that, we're invoking the add and the other line, the 1337, okay? Time to int, that doesn't work, okay? Int object has no time to int. So that's not gonna work, okay? So what we are going to do is we are going to have what we call type-based dispatch. So we will have two different methods. Okay. So we have the add operator. Okay, double under add. This is going to get invoked when it sees the plus sign, but we want it to work differently. If the other object is a time object, we will call add time. And if the other object is an integer, we will call increment. So we use if is instance is going to check, is the other object time class object? If that's true, then call self.addTime. And we have add time, and we're going to do self.time to int, other.time to int, and we're going to return int to time that. If the other object is not a time class object, so if is instance other time is false, so the else, it's going to return self.increment other. Self.increment other is designed to work with integers. So we just take self.time to int, and then the other part gets passed in as the seconds to add, and we add that seconds plus the time to int plus equals, so that now the seconds now has all of that combined, and it's going to return that, and that gets returned. So we have, depending on the type of object that other is, the thing that comes after the plus sign, is it a time class or is it something else? It will change how the plus operator behaves. So we have 9:45, duration is hour 35. I can say do start plus duration, and that works. It recognizes duration as a time class object. It converts that, adds it together, 9:45 plus an hour 35, indeed, is 11:20. Okay. I can also do start 9:45 plus 13:37. It's going to recognize that 13:37 is not a time class object, but it is an integer. So it's going to invoke the it's going to invoke this one, the increment. And it gets that. 10:07:17. Great. Okay. You can still call the methods directly without using the operator, the plus sign or whatever. So you can do that, and things like that. All right, and that works. Okay. So so that's great. The another thing. All right, what if I say, all right, well, I've got 13:37 seconds plus we're gonna add the start time of 9:45. Now this complains. It says, I don't know how to do that. Okay. Because earlier we had start plus 13:37 and I was able to do that. But if I do 13:37 plus start, Python doesn't know how to add time to an integer. It knows how to add integers to time, but doesn't know how to add time to an integer. And so if you want to have this kind of commutative property where you can do time plus an integer or integer plus a time, then what we have to do is we have to implement the right-hand add. Okay, so we have the add method, and then we can invoke the right-hand add. Okay, so right-hand add is just if the object that comes after the plus sign. So Python reads left to right. Okay, so if you have a time plus an integer, it's going to say, okay, I got the time object. I see the plus sign. Let's see the double underscore add comes an integer. Okay, I'm going to use add. Okay, but if you flip it around and you have integer plus time, again, Python reads left to right. So it reads, it sees the integer, then it sees the plus operator, and then it sees the time. And it goes, okay, integer, do you know how to add time to yourself? And the integer goes, no, I don't know how to do that. So then Python's going to say, okay, time, do you know how to add an integer to yourself if if you are on the right-hand side, okay, of the plus? And then time goes, yes, I have a right-hand sided addition. Okay, that's our add. And our add, we're just going to do, so the self is on the right-hand side of the plus. The other is in front of the plus. And all we're going to do is we're going to do invoke self underscore dunder add other. Okay. We don't have to do this business of is instance this and else that because we don't want to like copy and paste code. We just want to use code that already exists. So we're going to just call self dunder add other. Okay. And we're going to use that on the right hand side. Is that all right? So that goes that. So now I can do start 9:45 duration hour 35 start plus duration start plus 13:37 works. And now this one 13:37 plus start also works. Okay. All right. By having the right hand side that no longer produces an error. All right. This is the coolest thing, I think. I mean, not the coolest thing, but it's a very cool thing. So we have implemented underscore add. Okay. Right. We have dunder add. So look at this. I can now create 3 time objects, T1, T2, T3. I'm going to create a list, T1, T2, containing T1, T2, T3. And then I can call sum on that list. Okay. And it works. It works. I don't have to do anything else, okay? When you call sum, okay, sum on a list, that invokes the dunder add method. So we taught Python how to take a self and an other and add those two things together for time object. And that now generalizes anytime we have when it sees sum. Okay. So I can call, you know, T1 plus T2 plus T3 plus T3. And this works. Okay. I can create a list with all of these time objects and I can call sum and it works just fine. Okay. I could throw in an integer. Okay. I can throw in an integer and that also works. Okay. So if I've got T1, 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 T2, and I got T1, 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 T2, and 30, okay, that also works. I can just call sum on the list and it understands how to add all of these things together. So that's like that's really cool, right? Like now we can take our time class object and treat it like not like it's a number, but just we can throw it inside other things like lists and tuples and stuff, and we can invoke sum, and it doesn't just break it because it knows how to handle this as a way to add. Okay. What do I have? This very last thing, important tips. So yeah, you know, you can do this again. I hated it the entire time until I showed you init, but yeah, you can add attributes. I don't know where it is. Okay. Back here, you know, we can add attributes to, you know, hour, minute, seconds, and stuff like that. Again, not best practice, but you can. And if you ever need to check, like, okay, what are all of the attributes and what are all of the methods and stuff like that, you can call, it's not attribute, I mean, not methods, but the variables that are stored in there, you can call vars, okay? And it'll say, okay, we got hour 9, minute, 45, seconds, 0, and things like that. So these are things that exist. VS Code has a nice little we have Jupyter variables, okay? And you can see these things. So okay, and then and notice actually when you have start here, it gives you the string representation already now that we've defined string representation. But we have that. Let's see, can I further inspect this? No, I can't. Okay. But you can kind of, oops, keep track of all of that stuff. Okay, let me give you your last view quiz answer, which is the letter C, C as in cat. C as in cat is your last view quiz answer for today. Okay, that's it. So, I think you guys have homework 4. I'm gonna post homework 5 as well. I know it's like a lot of stuff. Homework 5 is gonna cover object-oriented stuff, and I know we just started it, but I'm going to just kind of post it now or like this week, and then we'll finish all of the other object-oriented stuff this week, and then you have until basically the end of the quarter to wrap up homework 5. But I will do that. Okay, all right. Have a great rest of your day. We'll see you.